how to work through some of the problems on the project. Please remember that you're still going to be working with the 3 forms: standard form, factored form, and vertex. So, to start that off, let's start with the actual forms themselves. You have y equals ax squared plus bx plus c for standard. For factored, you have ax minus r1 times x minus r2. And then the very last one, vertex form, y equals ax minus h. Please don't forget to square it, plus k. Please keep in mind that these a's are all the same, okay? There's going to be no difference. So as you're solving from one equation to the next, please make sure that these numbers are all the same. And in your cases, since we're talking about an angry bird, it goes up and then it comes down. They're all going to be negative as well. Okay. Now, most of the information that you are given is all going to be in some form of, they give you x-intercepts or a partial x-intercept and some kind of maximum height. No matter whether or not they give it to you in a graph form, in a table form, here where it's all written out, or here where you would have to then factor it, and then you could get those information. Please refer to your notes to go from one form to the next depending on which one you start with. However, the most prominent question that I was asked was how to use those factors in vertex. So I'm going to give you a basic problem. In this, I'm going to say that my x-intercepts are 8, 0, and 24, 0. And it tells you something about your max height is 40 feet. And we'll keep it yards as the project, so we'll say 40 yards. So, just to give myself a basic picture, it looks something like this. It comes up, it comes down. This is at 8, this is at 24, and we know that that max height is at 40. So, that is what we're looking at. So, to know every single quadratic we've known from the very beginning is perfectly symmetrical about the vertex. So, from this point, every single point is exactly the same. So, if you're looking at a table, from that high point, this point's going to match with this point. This point's going to match with this point. So on and so forth. They're going to have equal values. So we need to know where that middle is. To find the middle, you take your 2 intercepts and subtract them. We need to know what the distance is between them. And in this case, it's 16. So, I know that there's 16 spaces between here and here. This is your range. That's how long it's gone, how far it's gone. It's gone 16 paces, okay? So, to find out the middle, I'm going to divide that number by 2. And I know that there is, in this area, there's 8 spaces, and in this area, there's 8 spaces. So, 8 plus 8 spaces, I know that this is at 16, and that is the exact center. So, I know my vertex now is at point 1640. Please pause the video now if you need to go ahead and review that information or write it down for future problems. Now, knowing this information, we can then put it into either vertex form or x-intercept form. It is 100% up to you on which one you feel is easier to work with and manipulate. But if you notice, if I circled the A's, we have factors and we have this information, but we don't have what that A is, so we're going to solve for that now. So, I start with my original equation, y equals A, x minus r1, x minus r2. Plug in what you know. Well, here's my points. I still don't know y or a, x minus 8, and x minus 24. Well, I need to solve for a, so that means I need to plug in for an x and a y. In this scenario, I'm just going to use my vertex. It's the only other x and y that I have available right now. So I'm going to replace 40 with the y. X is 16. And I do that across the board. At this point, it is literally just an algebra problem, and you need to go through and just solve it algebraically. So, this is 8 and negative 8. Keep on solving, and you get negative 64. Divide negative 64 on both sides, and you get 40 over 64 equals A. And then, again, that is negative. When I simplify, this simplifies to A equals negative 5 over 8. Well, now I have A. So now you're ready to plug it back in to our adjusted formula. Y equals negative 5 over 8, x minus 8, x minus 24. That is our factored form. That is complete. There's nothing else we need to do with it. We don't need to manipulate it. We're all good. Okay. Now, for the next one, since I have my vertex and I have my A, I'm going to go ahead and throw it into vertex form. So, start with your original equation. Y equals, and I'm going to plug in A, x minus h squared plus k. And then, what is my vertex? 16 and 40. So, y equals A, x minus 16 squared plus 40. Now, we already know our A, but if we didn't, we could have used one of our vertexes. If we didn't go through this process, we could have used one of our x-intercepts here and plugged that in for an x and a y and solved for A. However, since we've already solved for A, we don't need to do that again, and we can just plug it in. And I have negative 5/8 x minus 16 squared plus 40. Completely done for that problem. So, we have factored here, we have vertex here, and the only thing you would need to do now is to distribute everything or FOIL it out and combine like terms to find your standard form. I hope this helped, and let me know if you have any more questions.